Hello, my name is Vatsal Parikh, and I'm going to do a software presentation on Natural Language Toolkit. So let's start. What is NLTK or Natural Language Toolkit? NLTK is a suite that contains libraries and programs for statistical language processing or pre-processing. It is one of the most powerful NLP libraries, which contains packages to make machines understand human language and reply to it with an appropriate response. A variety of tasks which can be performed using NLTK are tokenization, lemmatization, POS tagging, POS means parts of speech, and etc. Some of which I have applied in my project also, as I'm working with um, NLTK in my project. So yeah, a lot of data that one could be analyzing is unstructured data and contains human readable text. Before you can analyze that data programmatically, you first need to pre-process it, right? So, and those kinds of text pre-processing tasks can be done using NLTK. All right, so everything else is good, but what does natural language processing means? So, natural language processing is a process of manipulating or understanding the text or speech by any software or machine. An analogy, sorry, the analogy is that humans interact and understand each other's views and respond with the appropriate answer, right? uh, so in the form of text, right, we use normal text while we interact with each other. So in NLP, this interaction, understanding and response are made by computer instead of human. That's the only reason. That's the only difference. Some applications of NLP are web search, which can be done in Google, one of the, I mean, most famous search engine right now. Then grammar correction. Grammar correction can happen now in smartphone, um, keyboards, we can say. Then question answering. This can be done with a bot. Text summarization, that can be also done with a bot. I mean, the best example for a bot would be ChatGPT right now. Um, then machine translation, there's Google Translate, which is used a lot in backend for a lot of translation right now. And sentiment analysis is used in social media. So I think it's used by a lot of social media companies right now, because to control the traffic or to control the media, s- in any way, they are working sentiment analysis. And also in my final project, I'm working on sentiment analysis. So I'm using a lot of natural language processing stuff. So why should one learn natural language toolkit? Natural language toolkit can help us to learn new skills while also improving our NLP expertise. Learning natural language toolkit will help you add an extra skill and also enhance your knowledge of NLP. Next, I'm going to show some example. But before that, I'm going to show how to install NLTK in the machine. So suppose Anaconda is installed in your machine. So what you can do is go to Anaconda Navigator, and in the navigator, go to environments. In environments, you can see the base environment that's been installed when you install Anaconda in your machine. You can also create different environments with the help of this. So NLTK, right? So what we can do is to just search here NLTK, and it's gonna show for my environment. It's gonna show in install, but if it's not installed in your environment, you should go to not installed and just type NLTK. One more thing, the reason I'm using Anaconda Navigator instead of just pip install NLTK is that a package like TensorFlow, uh, it won't even show over here. The reason is TensorFlow actually affects with a lot. a lot of libraries which we use for model creation and stuff. Um, sklearn, I think it affects with sklearn in some way or something. I don't properly remember, but when I was trying to install TensorFlow, it did affect my environment, and I had to create a new environment and start again. So it's a good thing that it does not even show here, because there is some kind of mishap between them, I guess. Um, yes, so that's how you install NLTK. Next, I'm gonna show a tutorial code just to show how it works. And I have used half of the stuff in my project also, but there are also some stuff which I haven't used. So first, I'm gonna import NLTK. Okay, and I'm also if suppose we want to work with word tokenize and it's not installed in your PC in the environment, then what we can do is just do nltk.download. And okay, first I'm gonna okay, I'll start with it. Suppose we wanna download stopwords, so what we can do is just write stopwords inside the parenthesis and click enter. So it's gonna do all this stuff. But suppose we don't know which package, I mean, we don't know the package name. We are just browsing through. So what we can do is control enter, and it's gonna show all the packages and also the data set which we might be using. We might need to use in the process. So in my project and also over here for this tutorial, I'm using this open multilingual wordnet, and also stopwords I'm using. It shows it gives you the number of stopwords in its sentence. Wordnet is the dictionary of words. It contains synonyms and antonyms based on the relation it with other words. Word list also. Then in the model, you can find different models. These are all just the packages. Tokenizer, tokenization, it actually means that it divides the word into, I mean, it divides the sentence into multiple words. Text that I'm using in this, and yes. Also, if you want to change the directory, you can go from here and just change the directory. And yes, if you want to download some specific package, then you can just write the name over here. Okay, so I'm gonna start with stemming. So I showed this in the lecture, if I'm correct, but I was not able to properly explain what it means. So what stemming does is it removes it removes the later part of the word. So in this discovery, discovered, discoveries, and discovering, those originally mean discovery, right? So what's going to happen in stemming is so first you have to um, import the nltk.stem. I mean, yeah, import porter stammer, and then tokenize the words. So words are, I can actually show over here. Words are in a list. So words are in a list right now. The whole string has been divided into a list of words. Then what's going to happen is we have to call the stem function. So we can see discovery uh, has been reverted back to discovery with the I don't know how to pronounce this, but yeah, discovery. And discovered also um, convert has been converted to this other stuff. So this thing does not mean anything. Also this, so we can't really use this for any analysis. Lamitation, on the other hand, which I also showed in the lecture, what it does is it reverts back the word to its original meaning. So we call the word net lematizer function, and what it does is we can see discovery is the same discovery. For discovered, it has remained discovered, but for discoveries, it has changed to discovery. I mean, it does not work every time, lemmatization, um, but we can see for at least one of the use case, it did change from discoveries to discovery. If I try something, maybe like crying, I think cry. cry and cry, what's gonna happen is this thing is obviously nonsense, but this we can see the cry is gonna convert to cry. So even though lambdation does not work every time, it does revert back to its original meaning. Then the word net. So I already said that word net is a dictionary of words, and it can contain synonyms and antonyms in a for all the words in the English dictionary. And for our case, I'm using like over here as a word, and I'm gonna find other words which are synonyms to it and also antonyms to it. So if I run this and this, it's gonna give me that even though I mean correspondent is not like the synonym of like, but we can say as comparable. I think it's somewhat same, similar. Those are like much closer. So what happens is there is like a measurement inside which measures the likeness between two words, and if the likeness between two words are greater, then it gives back those words. So also the antonyms, you can see that this one is actually better. Antonym for like is unlike. You can also try something else like maybe laptop. All right, we can say laptop, computer, laptop. Those are synonyms, but there's nothing in the antonyms. So it does not work every time, but this is a good tool to have. Next is tagging parts of speech. This I haven't worked on before in my project or anywhere else. So what it does is tags the part of speech to the word. What part of speech means is noun, pronoun, adjective, and other stuff like that. So um, suppose the word is mountain. So what's gonna happen is it's gonna give you the list with mountain and the word and also the part of speech. Now, I took this quote from Spider-Man: "With great power comes great responsibility." And what I'm gonna do is tokenize it first. Also in tokenization, one more thing, we can see the responsibility and dot. Usually, if we um, just divide the words from the sentence, what responsibility and dot would have been in the same um, on the same index. But here we can see responsibility has been is different and dot is different. So that's also a good thing with the tokenization. Now the tagging part of speech tagging. What's gonna happen is first I'm gonna call the POS underscore tag function. We can already see that each of the words have been tagged with the respective part of speech. IN. So we don't really mean the we don't really know the short form of the word as IN. I don't remember, but what we can use is help.upen underscore tag set. It has all the short forms in it, and we can just check it anytime we want. So IN actually means yeah, preposition and conjunction. Also, there is a dot for dot. You can see. Um, I guess it's somewhere over here. Um, but yeah, this is also very useful. If we can identify it, suppose there's a um, customer chatbot or something, and first we know that the bot talks with us, and then we go to the actual person. So what happens is how the bot identifies a query is they identify the noun and other stuff from the sentence. So suppose our sentence was something like my laptop power is not working properly. So we know the power is a noun. So it's gonna give you all the respective articles or maybe solution they have in the data set in the database for power. And then if it won't work, then it's gonna get passed to the person, actual person. Next, chunking. What chunking does actually is it chunks the word. Chunks mean it groups the word together based on some condition, and the condition here is some kind of grammar. So for this example, we can see that I have taken JJ. JJ is a adjective and NN for the grammar. What this star means is that JJ, we can have any number of adjectives at the start of the sentence, and any number of noun. Sorry, not any number of noun, but only one noun at the end of the sentence. So it's gonna group all those words together, where this grammar is correct. We can run this and see what happens. Also, we use the regex parser over here to parse the grammar, and we are gonna create a tree with the help of this. Now we can see in the tree, it's not very big, but we can see S means the string, the whole string. So the sentence was with great power comes great responsibility, and the dot, right? And we can also see that the POS tag over here, the same POS tag, I and JJ, those are also here. But what we wanted to do, the chunking, that also we can see over here. That great and power, great is adjective and power is noun. So those have been chunked together. There is one more thing like chinking. So what it does, it divides the chunks. It's like the opposite of chunk, and that both chunking and chinking both are very useful in text processing actually. I can show you why it's useful over here with the use of this name entity recognition. So what named entity recognition does is each word can be identified by an entity. Suppose yeah, I'm gonna start with this only. Suppose Tony Stark. Okay, so this sentence is actually a synopsis of Iron Man movie, and I just copy pasted it over here because it contained some names and locations. So it was perfect for this. So we can say that Tony Stark is a name, right? Also Robert Downey Jr. Um, also, yes, America is a place. What else we can say? Uh, Maybe billionaire can be identified as a job. So those are all entities. Those are named entities, and there is a method in NLTK, any underscore chunk, which so actually there is a data set named entity inside NLTK, and those contain all of the name entities inside in that data set. So it checks for similarity in that data set, and this function gives back the entity. So suppose this is the text, and first we tokenize it, and then also we do the part of speech of that because that is very useful. Then we do the nltk.any underscore chunk. So also one more thing, any underscore chunk is the same as this. It just has the grammar. The data set actually contains grammar inside. So suppose to identify Tony Stark, it must be Tony is a noun, Stark is a noun. So it so everything that's a noun, maybe if it contains like two or three continuous noun, then it's a name. Maybe the grammar is like this inside the data set. Um, then to America. So maybe it checks to, I don't know what two is, but maybe America. It takes America as a noun, so it checks like if the first part is this, then the second. Wait, we can just check what two is where. Oh, the tree is gone. Okay, yeah, but it will show again here. Um, the tree that's built, this one is actually very big. So we can see already that Tony and Stark has been identified as a person, and also Robert and Downey. But we can see Junior has not been included in this. So it's not perfect like all the other applications, but yeah, it's working. Um, One more thing. Yes, string as is the root of all the other words, and America. So two actually means TO for some reason. Maybe we can check what it means. But yeah, America has been identified as GPE, and GPE means location. It's just a short form for location. So G what is it? The two, right? Yes. So there was TO. So it's a two as proposition. Maybe there's a grammar inside which says um, two and then the noun America. So if something like this, then it's a location. We can also see those having which are actually named entities. Instead of watching the whole tree, we can also do something like this. We can see also one more thing. Even though Tony and Stark are two different words, we can see they have been identified as one word. I mean, same person. They have been identified as same person. So that's also a very good thing with the help of grammar. And also, Robert Downey has been identified as a single person, and the location is America. So NLTK's built-in named entity tagger is not perfect, but for this text, we can see that it's working. And named entity recognition has multiple use cases, such as customer support, content classification, healthcare, or something like that. Overall, NLTK is one of the most essential tools for natural language processing, and these are just some of the tasks which can be done with it. And I think I'm gonna use more of it in my project also. We are using Vader, which is also um, a package from NLTK. Vader is a sentiment analysis model. All right, that's it from me. Thank you very much.